Why does sublimation create ice patterns like hoarfrost? Have you ever noticed those beautiful, delicate ice patterns that form on cold surfaces during winter? They are called hoarfrost, and they are a fascinating result of sublimation. So, what exactly is sublimation, and how does it lead to these stunning ice formations? Let's break it down. Sublimation is the process where a solid turns directly into a gas without becoming a liquid first. In the case of hoarfrost, this process is reversed. Water vapor in the air deposits directly as ice crystals on surfaces that are below freezing. This direct transition from vapor to solid is known as deposition. When water vapor meets a cold surface, the molecules attach themselves and arrange into crystalline structures. These ice crystals grow outward, often taking on intricate, feathery shapes. The unique patterns you see are due to how water molecules bond together in a hexagonal lattice when they freeze. The formation of these patterns is influenced by several factors, including temperature, humidity, and the texture of the surface. For instance, a rough surface might create different patterns compared to a smooth one. The colder the surface, the more pronounced the hoarfrost will be. Interestingly, sublimation does not stop once the hoarfrost has formed. When the sun warms the ice crystals, they can sublime back into water vapor without melting first. This means the crystals can gradually shrink or change shape while still maintaining their delicate appearance until they completely disappear. From a thermodynamic perspective, this process involves energy exchanges. When water vapor deposits as ice, it releases latent heat, which slightly warms the surface. Conversely, sublimation requires energy input to break the bonds in the ice, turning it back into vapor. These phase changes occur under specific conditions, where the air is saturated with moisture at temperatures below freezing. Understanding sublimation and deposition helps explain why you often see hoarfrost on cold, clear nights. During these nights, surfaces lose heat by radiation, and the air near them reaches saturation below freezing. This balance of vapor pressure and temperature favors direct solid-vapor transitions. In practical terms, knowing how sublimation works is important in fields like meteorology and climate science. Surface hoar can affect snowpack properties, energy balance, and even influence avalanche risk. So, the next time you see those beautiful ice patterns, remember that sublimation and deposition are at play, creating the stunning hoarfrost that brightens up the winter landscape.